So can you please try to solve this question? This one? Anyone? Anyone? Can you please find the solution for this question?
Sir, could you please show the question again?
Okay, so one student have already given the answer 50. Okay, you have to give some response because this response is also going to consider for your grade changing. If you are losing your grade due to 1 or 2 marks, then in this case we will consider your responses. Okay, so now check, most of the students are saying 15. Now I'm going to check whether you have given the right answer or wrong answer. Okay, so 210, what is the procedure to solve this problem? So first we'll write 210 base 3. 210 base 3. Okay, so 210 base 3, what is the decimal value of this number 210 base 3? Anyone? What is the decimal value of this number 210 base 3? What is the decimal value we'll get? 21. Okay, so 21, so we are writing 0, 1, and 2. So 3 to the power 9, 3 to the power 2 equal to 9, 9 into 2, 18, 18 plus 3. So, or you can also write like that in the simplest form, 2 into 3 to the power 2 plus 1 into 3 to the power 1 plus 0 into 3 to the power 0. Okay, so this value become 18 plus 3 equal to 29. Okay, so 21. Okay, to solve 21 and 2 hexadecimal, so we will write 16 here. So now what value will get here? What? This one is 5. So 1 5 with the right answer. Okay, 5 with the right answer. Now next one we will try the next one. This one we will try. 1 2 3 x base 3 equal to 1 2 3 base x, then the value of x h. Okay, even without solving this question, we can find the answer of this question. Without solving this question, we can find the answer of this question. Okay, can you tell me how we can find the answer of this question without solving? Okay, without doing any calculation, we will say the answer is D. Why? Anyone? Because just you can see, if we are going to take here x, what is the possible value of x? Maximum what we can write for x? Just will tell you. If you are taking the left side, what is the maximum we can write? Maximum we can write 2. Write 2. We cannot write 3. Either we can write 0, 1, 2. But when you are writing 2 here, then can we say this is a valid number? If the base is 2, can we write 3 as a valid number? Can we write 2 as a valid number? In this case, we will not find any solution for these types of equation. So directly we'll write none of these. So here there is no need to apply any calculation. There is no need to apply any formula. Directly first you have to check the possible value of x. And what you are saying like that, x is smaller than 3. Second time you are saying like that, x is greater than 3. That is not possible. Okay. Now for this one we will discuss. Okay. So for these types of problem we will discuss. Okay. So now you can see. So today we are going to discuss one important topic. That is how to convert any base to any base. So, as for example, if you want to convert base x to base y, base x to base y, okay, If we are going to convert base x to base y, then the procedure is first we have to convert base x to base 10 decimal value, and then we will convert the decimal value to base y. Then we will convert the decimal value to base y. Okay, so if you are want to convert base 5 to base 6, base 6 to base 5, then in this case the procedure is first you have to convert base 6 to decimal value, and after that for this decimal value again you have to convert to the base number 5. Okay, that is the normal scenario. I'm talking about the normal scenario. Okay, but when we are going for the binary conversion, that is the more important, because we are working for the computer system, and the computer system only understand the number in binary format, or you are writing the number in octal format, or you are writing the number in hexadecimal format. Okay, so these are the three standard. You can say binary means base 2, octal means base 3, and hexadecimal means base 4. Okay, base 4. Okay, now you can see here this is important point. Okay, if you are using the binary number means base 2, okay, what is the minimum number of bits? What is the minimum number of bits required to write all possible combination, or you can say all possible value of binary number? So what is the possible value of binary number? Either you can write 0 or 1. In a single place, either you can write 0 and 1. Now we'll tell you what is the minimum number of bits required to write 0 or 1. What is the minimum number of bits required to write 0 and 1? Anyone, can we say the single bit? In a single bit we can write 0, or you can write also 1. Okay, same like that if you are going for the octal number. If you are going for the octal number, in a single place, what is the possible value you can write? In a single place, what is the possible value you can write? Can we write 0 to 7? Can we write 0 to 7? Any value between 0 to 7? Can we write? Yes. What is the minimum number of bits required to write a single value in octal system? What is the minimum number of bits? If you are going to write in terms of binary number, can we say the minimum number of bits equal to 3? Can we say if you have the 3 bits, then you can write this number. Okay, same like that if you are going for the hexadecimal, the minimum number of bits.
Sir, how you calculate that it's 3 bits?
3 bits. Okay, so how we are calculating this 3 bits? Anyone can you tell me? I have already discussed one formula, log 2 base, the highest value. What is the highest we are getting here? 7 plus 1. What is the value we will get? 3. Because maximum you can write, just you can see maximum if you have the n bits. The number is only positive number. What is the maximum number you can represent? If the number can represent 2 to the power n minus 1. Can we write?
Why did you write 7 plus 1?
Yeah, just you can see why we are writing 7 plus 1. So 2 to the power n minus 1. Now I assume that the maximum number equal to x. Your maximum number equal to x. What is the value of n? Anyone can tell me what is the value of n? Can we write 2 to the power n equal to x plus 1? Can we write n equal to log 2 base n plus x plus 1? Can we write? Can we write?
Yes,
It's
sir.
a simple procedure. Okay. Now you can see. So I have already discussed. If you are going to write a binary number in a single bit, you can write single value. Okay. If you are going to write for the base number 4, then you need the 2 bits. If you are going for the base number 3 or octal number, then you need 3 bits. And if you are going for the base number 4, or also called the base number 16 or hexadecimal number, then you need the 4 bits to write a single number. Okay. Only you will remember this concept. Okay. What are writing like that? So if you are going to write the binary bit, then you will use only 1 bit. If you are going to write the base 4, then you will use 2 bits. If you are going to write the octal number or base 8, not the base 3, base 8. Here we have to make base 8, then in this case you will use the 3 bits number, and if you are going to write base 6, you will use the 4 bit number. Okay. Now we'll see how to convert any binary number to directly any base. Either you are going to convert to the base number 4, or you are going to convert to the base number 8, or you are going to convert to the base number 16. Okay. So now you can see the process. So as for example, we are writing this binary number 1 is 0, something like that. Okay. Now, if someone will ask you, this is your binary number, and you are going to convert binary number to octal number, or if this binary number to base 4, or this binary number to hexadecimal number. Okay. The normal procedure is what is the normal procedure? You have to find the decimal number, and then from decimal number, again you have to follow the procedure to find the base. Okay. Again, you have to follow the procedure to find the base. So, can you tell me what is the decimal number? Anyone? What is the decimal representation of this binary number? Anyone? What is the decimal representation of this binary number? 0, 1, 2, 3, 4, 4, 5, 6, 7. Anyone? Can you tell me what is the value we'll get? 7 means 128, 5 means 32, plus 8 plus 2. Just will take what is the value we are getting here? Anyone? 170. Good, 170. Now it should that if we are going to convert 170 to number 8, what is the procedure? We are going to write 8. What value will write here? Anyone? What is the quotient and what is the remainder value? Anyone? What is the quotient and remainder value if you are writing 170? Students are saying 21, some students are saying 22. Just will tell you what value will get here? 21. Okay, what is the value I am going to write here? Remainder value. What is the remainder value? Remainder 2. Okay, so whatever the most of the students are saying 22, so I have 21. Okay, now again we'll go for the 8. What is the quotient value we'll write here? Anyone? 2. And here what value we'll write here? Remainder 5. Okay, so now our final result is 25. Clear? Okay, anyone, any doubt here? This is a simple procedure. What we are going to do, whatever the number we are getting, first we are going to convert this number to the decimal number, and after that we are going to follow the procedure to convert decimal to some base number. Okay, but directly you can also find if the number is written in a binary number, directly you can also find the octal number, directly you can also find the base 4, and directly you can also find the base 16, base 32, base 64, something like that. Means it will only work for 2 to the power something base. It will only work for 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Something like that. It will not work for base 5. It will not work for base 6. Whatever the procedure I am going to explain, it will not work to convert base to base 6, base to base 5. It will only work to convert base 2 to base 2 to the power I, where I you can take from 1 to 8. Okay. Now you can see in the octal number I have already discussed. Just again we are going to write the number. What is the number we are writing here? 180, 180, 180, and 180. Fine. In the octal number, if you are going to represent the single bit, what is the minimum number of bits required? In a single number, if you are going to represent a single number, what is the minimum number of bits required? 3. Okay. Now, what you will do, you will start from right side and you will make the group of 3 bits. You will make the group of 3 bits. You will start from right side and you will make the group of 3 bits. Here we are getting only 2, so we will add a 0. Because you already, if we are going to add 0 before the positive number, the number will not change. If we are going to add 0 before the positive number, the number will not change. Okay. Now will tell me if we are writing 0, 1, and 0, what is the decimal representation of only 0, 1, 0? What is the decimal representation of 0, 1, 0? 2. So we are writing here. What is the decimal representation of 1, 0, 1? 1, 0, 1. Anyone? Fine. What is the decimal representation of 0, 1, 0? What is the decimal? Can we say this value same like your this value? Can we say? Can we say the both the values are same? Just you can see the procedure is very simple. Again, I am going to write 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, something like that. Okay. If we are going to find the decimal value, again it will take time, and then you have to convert the decimal to octal value. Again, it will take time. But if you are using the shortcut approach, how to find? We have to make the group from where? From line. Just you can see we are making the group of 3 bits. Then 1, 0, 0. Then we are making 1, 0, 0, 1, 1, 1, 0, 2, 0. 1. This one is 1. 1. 3 bits, 3 bits, 10 bits. Now we'll tell you what is the decimal representation of 0, 1, 1. 0, 1, 1. What we can write? 0, 1, 1. 3. 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. 1, 1, 0. I'm talking about 1, 1, 0. 6. Good. 6. Then 0, 0, 1. 0, 0, 1. 0, 0, 1. What value will write? 1. Then 0, 1, 1. 0, 1, 1. Then 1, 1, 0. 6. Now you can say this is your final answer. You see, the final answer that will not take too much time. Okay. Same like that. If you are going for the hexadecimal, then in this case, that will see how this method is working. We'll see. If you are going for the hexadecimal, then again what we will do? 1, 0, 1, 1, 1, something like that. We are writing here 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0. Now we will take the group of 4. Okay, we will take the group of 4. We are taking the 0, 1, 1, 0, 0, 0, 1, 1. And this. Now will tell me 0, 1, 1, 0. What is the decimal value of 0, 1, 1, 0? What is the decimal value of 0, 1, 1, 0? 6. We are writing 6. What is the decimal value of 1, 1, 0, 0? 1, 1, 0, 0? 1, 0, 12. So can we write 12 in the hexadecimal? Can we write 12 in the hexadecimal? In place of 12, what we can write? We can write C. 1, 0, 1, 0, 1, 0, 1, 0. What value we can write? 1, 0, 1, 0. What value we can write? 8. So in place of 10, what value we will write? Okay. So now you can see this. Can you please try to find what is the answer of this question? Anyway. Hexadecimal.
Sir, can you repeat that part again, that alphabets part?
Yes, alphabets means in the case of hexadecimal, if you are getting 10, that will replace by using A. Because in the single place, you cannot write 10, so you have to write A. 11 means we have to write B. 12 means we have to write C.
Got it, sir.
13 means we have to write D. 14 means we have to write E. And 15 we have to write F. Okay. We will find what is the hexadecimal equivalent of this number. Now I am going to make as a separate one, 4 bits. Then again, this is your 4 bits. Again, 4 bits. Again, 4 bits. Now we'll calculate. Okay, so within a second, you can calculate the value if you know this string. If you know this string here, within a second, you can calculate this value. How to find this value? What is the value of 0, 0, 1, 1? 0, 0, 1, 1? What value we can write? 3. So now you can see only one number is last 3. So definitely the answer is. Definitely we can find the answer. You see, they don't need to check for the other number. If you are for the option Y directly, we can write 7 C D E 3. Okay, or if you are going to check, this is your 3. This one become what value? 14. In place of 14, we can write E. This one become 8 plus 4 plus 1, 13. 13 in place of 13, we are going to write D. This one become 12, so we are going to write it C, and this one become your 7. So 7 C D E 3. 7 C D E 3. Okay. Now this one, what is the value we can write? Which one is the right answer? The 2s complement representation of minus
can you show the previous number
539
once again, sir, please?
base 10 in hexadecimal H. The 2s complement representation of minus 539 base 10 in hexadecimal H. What is the answer we'll get? Anyway, first we have to write what is the 2s complement of minus 539. That we have already discussed in the previous class. What is the 2s complement of minus 539? What is the shortcut method? Shortcut method. You have to find what is the power of 2 that is slightly greater than 539. Anyone? What is the power of 2 that is slightly greater than 539? 4. So in the 10th position, we are going to write 1. In the 10th position, we are going to write 1. So 1 10 that if you are writing position 1, what is the value we are getting? 1024. 1024 means minus 1024. What value we have to add to 102 to get minus 539? What value we have to add? 485. Okay, so 485, how to write 485? Just you have to follow the procedure to write 485. Next bit is your 9th bit. Can we write 1 in the 9th bit? 2 to the power 9. What is the value we'll get? 2 to the power 9? 512. So we cannot write, so we are going to write 0. Now eighth bit can we write 1? Yes, we can write 1 because 2 to the power 8 is 256. So we are writing 1 here and we are subtracting minus 256. What is the value we'll get? If we are going to subtract 485 minus 256, what value we are getting here? 229. 229. Now the next bit can be write 60 because this is 128. Next bit here 64. Again, yes, we can write 64. So we are writing minus. Okay, sorry. 256 means next bit your 128. 128 minus 128. What value will get? Minus 128. What value will get? This is your 128. So 10. Next bit we are getting the 64. Okay. So we are writing here 1. Again we will subtract 64. What is the value we'll get? 101 minus 64. 101 minus 64. 37. 37. Next bit your 32. We will write the 32. Minus 32. What is the value we are getting? 5. Next bit your 16. We cannot write 16. Next bit is your 8. We cannot write 8. Next bit is your 4. We can write. Next bit is your 2. We cannot write 2. Next bit is your 1. Now this is your final answer. So what is the answer we are getting here? This is the 2s complement 1 0 1 0 1 0 1 1 1 1 0 0 1 0 1. Okay. Now if you have no any idea about this trick, what is the formula? First we have to convert 539 to the binary value, and then after converting 539, you will find the 1s complement. That will add 1 to the 1s complement. You will get the answer. Okay. Now we are going to convert to the hexadecimal. How to convert? Again, we have to make the 4. Just to see. 1 2 3 4 4, and again we are writing here 0. Now we'll tell you what is the value we are getting here. This one. What is the value we are getting here? 5E5. Most of the students are saying 5E5. So I'm going to consider the same answer. We will check one option. There is no option called 5E5. It is coming A, B, E, D, B, C, D, E5. Okay. So now again we have to check because somewhere we are doing some mistake. That's why this answer is not coming.
Sir.
Yeah.
Shouldn't we write 1, sir, in the beginning? Should we write 0?
Okay. We cannot write 0. We can write 1. Right. Because this is a negative number. This is your negative number. We have to write 1. You will not write 0. We have to write 1 because this is a negative number, and that we have already discussed. If we are going to add 1 before the negative number, the number will not change. So here, what we are getting here 1 1 0 1. Then we are getting 1 1 1 1 0. Then we are getting 0 1 0. Now we'll tell you what is the answer we get. What is the answer we will get? DE5. So the answer we are getting here DE5. C is your right answer. Here. So why we will not add 0? Because the number is negative. In case of negative number, we have to add 1 before the number, not the 0 before the. Now we check this one. What is the answer we can write? Okay. That we can also see the trick. Okay. Now, I think you got the concept how we are going to convert a binary number. How we are going to convert base 2 to base 2 to the power I. Clear? Now we'll see how to convert any base 2 to the power I to base number 2. How to convert any base 2 to the power I to base number 2. Again, the procedure is okay. So as for example, if we are writing here A, B, 5. Okay, and this one your base number 60. Base number 60. Okay. In the base number 60, what is the bits we are using? What is the bits we are using for the base number 16? We are using the 4 bits. Okay, we are using the 4 bits. Now, same like here also, whatever the number is there, you have to write that number using the 4 bits. You have to write the same number using 4 bits. So if you are going to write 5 using 4 bits, if you are going to write 5 using 4 bits, what we can write? Anyone. 0, 1, 0, 1. Same like that, if you are going to write B using 4 bits, how to write B using 4 bits? B means basically we are getting 11. So how to write 11 using 4 bits? Because B means basically we are getting 11. So how to write 11 using 4 bits? So this one your 8. We are not going to take 4 to 10 and 111. Same like that A. How to write A using the 4 bits? You write 1 0 1 0. Now you can see this is the binary representation. This is the binary representation of your this hexadecimal number. This is a binary representation of this hexadecimal number. The procedure is very simple. Same like that, if you are going for the 767 base number 8 to binary number base 2. First, this is a base number 8. What is the minimum number of bits required to write single digit in base number 8? What is the minimum number of bits required for single digit? 3 bits. Okay, so how to write 7 into 3 bits? 111 is your 7. How to write 6 using 3 bits? 110 110. How to write 7? 111. So total answer we are getting 111, 110, and 111. This is your final answer. Clear? This is your final answer. So now we'll try to solve this question just with this one. What is the answer will be? And after that, there is no any method to convert 8 to 4. You have the procedure is you have to convert 8 to binary number, and after that the binary number to base 2 to the power I. After that you will convert a binary number to base I 2 to the power I. Okay. When you add 1, where we are adding 1? Where we are adding 1? This one is not a 1. We are making as a box. This is not a 1. We are making as a box. This is not a 1. We are making as a box. Okay. So now we'll try to solve this question. That's what. How to solve? No, this method will not work to convert 3 to the power. This method will only work to convert. Okay, I'm going to explain minimum number of bits. Okay, and this method is only work to convert. This method is only work to convert 2 to the power I or 2 to the power I to base. Okay, it will not work for other cases. Okay. Now you can see one student is asking about the minimum number of bits. Okay, minimum number of bits. Okay. Now you can see that we have already discussed in the first class. Okay. If you are going for unsigned integer, okay, unsigned integer, what is the range you can write with using n bits? If you are going for the unsigned integer, what is the range you can write using n bits? 0 to 2 to the power n minus 1. Can be right? Can be right? 0 to 2 to the power n minus 1. Up to here, anyone, any doubt? Why we are writing the range 0 to 2 to the power n minus 1? Anyone? Any doubt? If you have any doubt, just put in the chat box. Okay. 0 to 2 to the power n minus 1. This is the range for a kind number. What is the range for 2s complement? 2s complement. What is the range for 2s complement? Minus 2 to the power n minus 1. To the power n minus 1 minus 1. Okay. If you have the doubt, just go through the previous recorded lecture. Same like that, if you are going 1s complement or signed magnitude number, you can represent the number minus 2 to the power n minus 1 minus 1 2 to the power n minus 1 minus 1. This one is minus something. Clear? Clear? Up to here, anyone, any doubt? No doubt. Okay. Now we are going for the hexadecimal. Okay, hexadecimal. In the hexadecimal, what is the maximum number we can get? In the single place, what is the maximum value we can get? If you are writing hexadecimal, what is the maximum number you can write in a single place? Anyone? What is the maximum number you can write in a single place? 50, not the 60, because you are always writing the remainder value. So either we can write 15 or we can write f. Clear? Either we can write 15 or we can write f. Okay, but normally we are not going to write 15 in a single place. That's why we are using the term called f in terms of hexadecimal. Okay. Now after that, I need what is the minimum number of bits required to write 15? What is the minimum number of bits required to write 15? Now assume that we have no any idea. We are going to assume like that. The minimum number of bits required to write 15 equal to. Can we write the minimum number of bits required to write 15 equal to if we are going to assume if the number of bits equal to n, what is the maximum number we can write? What is the maximum number we can write? Anyone, what is the maximum number we can write if this number the number can be write to the power minus 4? Can be right? If this is a number of bits, we are saying number of bits. If the number of bits equal to n bits number, what is the maximum number you can write? 2 to the power n minus 1. Okay. If we are going to write 15 using it, definitely this value is smaller than equal to. Then we can say like that. With using this n bit, we can write 15. With using this n bit, we can write 15. Okay. Now, can we write 2 to the power n minus 1 greater than equal to 15? Can we write the same? 2 to the power n greater than equal to 16 and n greater than equal to 4. Can we write n greater than equal to 4? The value of n greater than equal to 4. What is the minimum number? Minimum value. What is the minimum value of n? Anyone? What is the minimum value of n? 4. So that's why in the hexadecimal we are taking the 4 bits. If you are going to write hexadecimal in terms of binary number, then you need minimum 4 bits to write a single number. You need minimum 4 bits to write a single number. For the octal number, if you are going for the octal number, what is the minimum number of bits required to write a single number? 3 bits. Minimum number of bits required to write a single number equal to 3 bits. Clear? So anyone, any doubt how to convert hexadecimal to number? Okay. Clear? Okay. Now the question is how we are going to store the character value. For integer value, you already know how to store the integer value. But now we'll see how to store the character value. How to store the character. So here basically we are using one table called ASCII values. Okay, ASCII value, and we will only remember the ASCII value of 2 numbers. Just you can see here. You can see if you are going to check, this is the ASCII value. We are going to check for the capital A. So this is your hexadecimal. It is written in the hexadecimal decimal. Okay. So decimal means that this is your hexadecimal format is written. Yeah. If you are going for the capital A, it is represented 65. If you are going for a small a, it is represented using 97. Now you can see this is a very important point. Okay. So capital A means the ASCII value equal to for a capital A, the ASCII value is 65, and for a small a, what is the ASCII value? What is the ASCII value for a small a? Just you can check the table, and we are writing the decimal 97. That is your 97. This is your ASCII value. What we are writing here? 97. You can see 97. We are talking about the decimal, so 97. Okay, so we are writing 97. Now the same like that will go for that. So we are going to write here. 97. Okay. If you are going for B, what is the hexadecimal representation? Sorry, what is the decimal representation of B? 66. Decimal representation of C? 67. Same like that, small b, 98 and 99. Okay. Clear? The character value we always write in a single quote. Character value we always write in a single quote. This is very, very important. Okay. Very, very important. As for example, just you can see C++. I'm going to make the new file. Save it and called A1.c. Okay. Now I'm going to write the same code. There's no need to write the math. Main. Now we are writing character C to A. Okay. And you are going to print the value of C printed. If you are writing percentage E, C. What value it will print? Anyone. What value it will print? Return. Okay. What value it will print? For what is the ASCII value of C? So that is your 97 will print the value equal to 97. Okay, it will print the value equal to 97. Same like that, if you are writing percentile C, it will print you the value called C. Just to get it. So if you are going to print character value, you have to write percentile C. If you are going to print the integer value, you have to write percentile D. Now, if I am going to write 1 here, what value will print if I am going to percentile D? Okay, if you are going to write percentile D, what value? It is printing 49. Why it is not printing 1? Anyone? Why it is not printing 1 if I am going to write here 1? Why it is not printing? Because whatever the 1 we have written here, this is character 1. This is not a integer 1, because both are different. If we are going to write here, just because 1 plus this 1, what value will get as answer? What value will get? If you are writing 1 plus single, what value will get? This one will consider as a character. When you are writing anything in terms of single quote, that will consider as a character. In case of character, you have to find the ASCII value, and here you can see the ASCII value of 1 equal to 49. Just you can see ASCII value of 1. This is your character. What is the ASCII value of character 1? That is your 49. So here we are going to write, give you the value. What value it will print? Anyone? What value it will print? So it will consider this one equal to 49 plus 1 equal to 50. 49 plus 1 equal to 50. Just you can see. So don't be confused. Sometimes the question will come like that. You can see. If it will write like that. So A equal to 1, and then it will write if A equal to single quote 1, and that will write a printf bits, and then it will write printf. Yeah, printf. Now, what value it will print? If this condition is true, it will print bits. If this condition is false, it will print. So if this condition is true, can we say this condition is true? A double equal to single quote A. Can we say this condition is true? This condition is false. It will print only the header. Just you can see, if you are going to execute, it will print header. Clear? So don't be confused between the integer value and a single quote. I have already mentioned this is very, very important for your exam point of view, placement point of view, and also for the gate point of view. If you are going to write anything, 5 single quote is not equal to normal. Okay, 5 single quote is not equal to normal. Okay. Now the next most important part. Okay, this is the most important part also. Okay, the size of integer. Normally the size of integer. Value of A as a 49. Can you please check the value? A as a 49 means what you want to check. Okay. So you make as this one A equal to 49. Okay. Compile and run bits. Clear? So if you are going to make add A as 49, then it will return the true statement because the ASCII value of 1 equal to 49. So we are writing 49 equal to 40. Clear? Now you can see by default, whatever the variable you are going to take, as for example, here we have written int A. By default, it is called a signed number. I already discussed. There are 2 types of number. One is called the signed number, and second one is called the unsigned number. Unsigned number is only positive number. Unsigned number is only positive number, and signed number is both positive as well as negative number. Okay. So if you are writing normal here, if you are writing normal like character A, or if you are writing integer A, or you are writing float A, means basically creating the unsigned number, not the unsigned, signed number. In the case of signed number, what types of representation the compiler will follow? Sign magnitude or 1s complement or 2s complement? Anyone? What types of representation will follow? What types of representation it will follow? 1s complement, 2s complement, sign magnitude, 2s complement. Okay, because nowadays we are only using 2s complement. Unsigned number, if you are writing unsigned number means normal cases, it will not follow any types of complement. Okay, that is called the unsigned. Okay. Now the most important part, the character value, whatever the character variable you can say, that will take 1 bytes of memory. Okay, so if you are going to create any character variable, that will take 1 bytes of memory. That is fixed. If we are going for the integer, it will take 2 bytes of memory, or it will take 4 bytes of memory. It will take 2 bytes of memory or 4 bytes of memory. It will totally depend upon your compiler. Okay, the size of integer is not fixed. The size of integer is not fixed. It will vary from compiler to compiler. Okay, it will vary from compiler to compiler. But the size of the character is fixed. It will take only 1 byte of memory. Same like that, if you are going for the float number, means the real number, we are going to store the real number 5.2, 5.5, something like that. That will be stored in a float variable, okay, float data type, and the size of the float data type is your 4 bytes of memory. The size of the float data type equal to 4 bytes of memory. Okay, out of this 4 bytes, some bytes is used to store the decimal number, and some bytes is used to store the decimal. Clear? Now, this one always you will remember. The character size is your 1 byte. Integer the size is your 2 bytes, and float the size equal to 4 bytes. Okay. If the size of the character equal to 1 bytes, what is the maximum number you can represent and what is the minimum number you can represent? If the size of the character is 1 bytes, what is the maximum number you can represent and what is the minimum number you can represent? The max, I have already mentioned, if you are writing normal character B or character variable, that will consider as a signed number, that will consider as a signed number, not the unsigned number. Whatever the answer you are giving, that you are giving in terms of unsigned number. You are giving in terms of unsigned number. I am talking about the signed number. If you are writing the character B, if you are writing character B equal to whatever you are writing 5, what is you are writing 5, it will consider as a signed number. In case of signed number, what you are getting? Minus 128 to 127. Minus 128 to 120 by default. If you are going to create forcefully, if you are going to create unsigned number, then you have to write unsigned. Okay, so as for example, here you can see we have to write like that. So now you can see, here you can see, this is also important one, character C. Okay, now we do that, you have no any idea what is the number of bytes to this value. You have to use the object called percentile D, and then you will write here size of C. Okay, size of C. Now you can see what value it is representing 1 byte. Same as writing here integer. If you are writing here int D, and then you are writing percentile D, size of D, now you can see how it's going to store. It is taking 4 bytes of memory, but that is not the fixed value. Okay, it will vary from the compiler to compiler. Some compiler it will take 2 bytes of memory, and some compilers it will take 4 bytes of memory. Okay, now here you can see what I am writing: unsigned character D. Okay, unsigned character D, and here we are writing equal to 128, and here we are writing character D equal to also 128. Okay, percentile D. Then we are going to print the value of C, comma D. Now we tell you what value it will print. Okay, it will totally depend upon the compiler. It will totally depend upon the compiler. The compiler will decide the size of the image. Okay. So if you are designing the compiler, it will decide about the size of integer, whether you are taking the 2 bytes or you are taking the 4 bytes. So based on the requirement, you have to check. Okay. So now you can see. So can you tell me what value it will print if you are writing percentile D, what value? What value it will print? Anyone? What value it will print? I have already given you the idea about the cycle. Okay, so first one you can see, the first one character C equal to 128. First one your signed character or unsigned character. First one your signed or unsigned. First one your signed or unsigned. First one signed or unsigned, signed character. Now we make these types of cycle. Okay, these types of cycle, and we will start from 0. We make here 127. And then after 127, we will make minus 128, and then we'll come to here. Can we make these types of cycle? Can we make these types of cycle? Only for signed. Okay, if you are going for the unsigned, there is no any problem. You have to write 0, and this one will start from 0. It will come to the 227. Again, it will start from 0. It will come to the 255. Now you can see we are going to store the 128. Can we store 128 in this variable? Can we store 128 in signed number? Can be stored? Can be stored? Actually, we cannot store, but by default, what can be stored? It will follow these types of cycles. It will store what value? Minus 128. But in the case of unsigned, can we store 128? Can we store 128 in case of unsigned? Can we store? Yes, definitely we can store 128. So here you can see if you are going to execute this program now, you can see what value it is printing. Minus 128, 128. Why it is printing minus 128? Because this is your signed number. Same like that if you are writing here 256. And here you are also 256 value. Just will tell you what value to print if we are writing character C equal to 256, and again here you are also writing the character D equal to 256. What value it will print? Anyone? What value it will print? It will print the value equal to 0, 0. Now you can see it will print the value equal to 0, 0. Okay, so same like that when you are working for any type of problem, first you have to check the range of this variable. First you have to check the range of this variable. So as for example, now you can see if you are going to store integer, normally assume like that for the ATM system, and you are going to store account number. Okay, you are going to store account number. If you are taking integer value, to store the account number, it is taking only type of memory. Maximum you can store the account number value, whose value is smaller than or 60 minus 1. If you are using the unsigned number, maximum you can store to the power 16 minus 1. 2 to the power 16 minus 4. Clear? So I think during my PhD, we have developed one system. We have developed one normal system that is used to manage the gate exam, that is used to manage the gate admission. So that time, what will happen like that? We have used one variable D to store the account number of the student. So what will happen like that? Whatever the account number of the student that is related to the SBI has only 10 digits. But if you are going for the ICICI Bank, the account number, the number of digit in account number equal to 15 digits. Okay, 15 digits. But that time when we have designed the software, that time we are going to assume like that means all the account number is only 10 digits. Whatever the account number, either you have the SBI account or HDFC account or ICICI Bank account, or account number. That's why we have taken the variable int D to store the account number. What will happen like that? Those students whose account number is in ICICI Bank, we are storing the wrong account number. We are not storing the right account number. Why we are not storing the right account number? Because if you are taking integer, that will only store the limited value. It store the beyond limited value, not store the beyond limited value. So what will happen like that? So when we have used, our system, the college have used this software to refund to the student. Those students who have already decided to take that admission in different college, they have decided to refund. Okay, so when they have refunded this amount, actually that amount will not go to that account. It will go to some other bank account. Okay, because whatever we are assuming like that, we are storing the right account number, but we are not storing actually the right account. So that time, actually approximately 3 to 4 crore rupees that will go to the different account number. Means whatever the account related to the ICICI Bank, that will go to different account number. So after that, we have to approach to the bank. Then after that, I think it will recover up to 2 point something crore. So that is the loss. So when you are working for any type of requirement, first you have to carefully will check the range of the variable, and based on the range of the variable, you have to decide the type of the variable. You have to decide the type of the variable. And here I have already discussed about the 3 types of the variable. That we will discuss more in detail in the next class. What is the different type of variable? But before that, we will start the flow. chat. So that is totally new topic. So whatever the number system is there, we have already completed the number system. And definitely some question will come in your exam related to the number system, and that is also important for your placement point of view. Okay, placement as well as the gate point of view. And we also discussed what types of questions you can expect in your exam related to the number system. Clear? If you have any question, then please ask. If you have any question, then please ask. Anyone, any question?
Sir, where can I find the recording of previous classes?
It is already there in the Google Classroom. So just go through the recorded lecture, you will find.
Okay, thank you, sir.
Sir, can you explain binary to 2 to the power I again?
Binary to 2 to the power I. Okay, what we are saying like that, if we are going for the 2 to the power I, means base 4. Okay, what is the value of I? If you are writing base 4, what is the value of I?
2.
2. Okay, so we will start from the right side, and we will make the group of 2 binary number. We will make the group of 2 binary number. Then we will find the decimal number. That will you are getting the overall base 4. Same like that, if you are going for the base 8, what is the power of 2 to the power I for base 8? Of I? 3. So now we will start from the right side. We will make the group of 3 numbers and find the decimal number of these 3 numbers.
Okay, got it, sir.
Yeah.
Sir, I have a doubt.
Yeah.
So, then I'm writing a code, so like character A and printing the size. So,
Yeah.
sir, I always have to put like double quotes percentage LD. It's not considering only D. It's saying like it's a long integer. So even if it is taking only 1 byte or 4 byte of memory, so then also why is it asking for like long integer values?
Which one?
So whenever I'm printing the size of any like character or any integer.
Just to say that size basically return the long time. Size basically return the long time. That will see more when we will discuss about the size of operator. Okay, but currently we are writing percentile, but if we are talking about the return type of the size, that is your long time. And we have not discussed for the long time, that's why we are writing here LD. Okay? Yeah.
Sir?
Yeah.
Sir, can you hear me?
Yeah, tell me.
Sir, as I'm new to the in this batch, so like all my except this class, all my classes I can't access it because it is not being added on the Google Classroom, and either the Google Meet link comes on the Gmail account. So whom I have to contact from here?
Okay, just share your this one mail ID in the chat box.
Yes, that's just 1 minute, sir.
Sir?
Yes.
Sir, is it better to use unsigned integer, like in case of the bank accounts example you just said?
Yes, unsigned integer.
Because you can store more bits of a number. Like
yes. Yes.
So I didn't understand the part where you said, like in the previous example, like money went to different accounts. I didn't understand why that happened.
Why that happened like that? If you are going to calculate the 2 to the power 16 minus 1, what is the value it will come? If you are going to calculate 2 to the power 16 minus 1, 16 minus 1, just we will check what is the value it is coming. We are going to check the 2 to the power 60 or 2 to the power 32 minus 1. If you are going to check, it will come the 10 digit number.
Yes, sir.
If you will check carefully, it will come the 10 digit number. Means maximum you can store the 10 digit number if you are taking the here integer. If the integer our compiler is taking 4 bits, we will store the 10 digit number. Okay. So that time we have assumed like that all the means bank have all the 10 digit number, and that is the sufficient. Okay.
Yes, sir.
Now what will happen like that if you are going to ICICI bank that has a 15 digit number, but can we store the 15 digit number in 4 bits? We cannot store. So it will store some different number. Again, it will follow the cycle and it will store some different number.
Yes, sir.
What is my point? So that's why if you are going to store 128, just you can see. Character C equal to 28. What value it is storing? Minus 128. What you are going to assume like that? I have stored 128, but actually it is storing
minus 128 because it's beyond its capacity that it can store.
Yes, yes. So after that, whatever the calculation we do, can we say we are getting the right answer? Can we say we will get the right answer?
No, sir. It'll be stored in another form in binary, so
Yes.
it'll transfer to a different account.
Yeah. So I think I have already sent you the invitation mail for the Google Classroom. Please accept and join the Google Classroom. You can access all the recorded lectures.
I have access of all your lectures, but the other classes I can't access.
So other
That
classes will contact to the instructor, other instructor. This is only
like
for computer programming. This is only for computer programming. If you have
yeah.
any question related to the other subject, then will consult to the IC of that subject.
Okay, so how can I contact sir? Like the contact
Just
details
will
of
check the name. Just will check the name, and then you have to mail it.
Okay, sir. Okay.
Anyone? Any doubt? Question? Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. And next class
Thank
is
you,
very
sir.
important.
Thank you,
so
sir.
don't miss the next class. The next class, we are going to start the flow chart. That is the actual your C programming. Whatever we have discussed, that is not the part of computer programming. That we are only going to use this concept during the programming. But tomorrow is from the next class, we are going to start the flow chart. Okay.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thanks.
Thank you.